Welcome back to the SnakeBros Kids YouTube channel, where we're exploring the amazing story of life on Earth. Today we're starting at the very beginning, way back before dinosaurs, before trees, even before the first squishy jellyfish. We're asking a huge question: where did life come from? Part 1. What is life? First, let's figure out what we even mean by life. How do you know if something is alive? Well, living creatures, large and small, usually do a few special things. They react to the world around them, they eat or take in energy, they grow, they make more of themselves, that's reproduction, and eventually they die. All of these steps together are called a life cycle. The word biology actually comes from Greek. Bios means life and logos means study, so biology is just the study of living things. Pretty cool, right? But here's the mystery. Where did the first life come from? The truth is, no one really knows. Some scientists even wonder, what if life started somewhere else in space and traveled here? But then we'd still have to ask, where did that life come from? Big questions. Part 2. The energy for life. Here's what we do know. All life needs energy. On Earth today, most energy starts with the sun. Plants soak up sunlight and turn it into food through a process called photosynthesis. Then animals eat plants and other animals eat those animals. That's the food chain. But wait, what about places deep in the ocean where the sun never shines? As long as there is a source of energy and liquid water, life seems to be happening. Believe it or not, scientists discovered strange creatures living around boiling hot hydrothermal vents. This geological activity provides the chemical energy to fuel the life in the ocean's deepest and darkest spots. Animals called extremophiles are creatures that love boiling heat, crushing pressure, or even acid. Life is pretty amazing, huh? We'll learn more about these wild forms of life in later episodes. Part 3. A quick detour. Matter everywhere. To understand how life began, we need to zoom out and talk about the stuff that makes up everything. Matter. Matter comes in different states. Solid, like a rock, with particles packed together tightly. Liquid, like water, flowing to fit its container. Gas, like the air we breathe, spreading to fill any space. And plasma, the super hot, electrified state that makes up stars, lightning, and even neon lights. Fun fact, 99% of all the ordinary matter in the universe is plasma. That means most of the universe is glowing, fiery star stuff. Stars make a lot of energy, but they are too hot for life as we know it to exist. Part 4. Habitable Worlds. So what makes a planet a good home for life? Scientists look for planets in the habitable zone, also called the Goldilocks zone. That's the distance from a star where it's not too hot and not too cold, but just right for liquid water to exist. And water is one of the biggest clues for finding life. Earth also has a protective magnetosphere, an invisible shield made by Earth's magnetic field. It protects us from harmful solar radiation that could damage DNA. Without the magnetosphere, life might never have a chance to form. Part 5. Chemical evolution. Now let's time travel about 4 billion years back to the early Earth. Imagine a planet covered in volcanoes, lightning storms, and bubbling oceans. Scientists J.B.S. Haldane and A.P. Operin had a big idea in the 1920s. What if Earth's oceans were like a giant soup filled with chemicals? They thought lightning and sunlight could have sparked reactions that made bigger, more complicated molecules, the building blocks of life. In the 1950s, Stanley Miller and Harold Urey tested this idea with a famous experiment. They put gases like water vapor, methane, and ammonia into a sealed jar, zapped it with electricity to mimic lightning, and after a week, the water had turned brown and contained amino acids, the stuff proteins are made out of. They didn't create life, but they showed how the ingredients of life may have formed naturally. Scientists now think that Earth's early atmosphere was a little different from Miller's experiment, but even with those changes, similar experiments still make complex organic molecules. And we've even found amino acids in meteorites from space. That means the building blocks of life might be scattered across the universe. Part 6. Luca and the First Ancestors. Scientists believe all life today, from bacteria to blue whales, share a single ancient ancestor called Luca, the last universal common ancestor. Luca wasn't the first life, but it was the last ancestor before life branched out into bacteria, archaea, and eukaryotes, like us. Luca might have lived near hydrothermal vents in the ocean using chemical reactions for energy in a world without oxygen. Imagine that. Every plant, bug, and person alive today can trace their family tree back to this mysterious microbe from billions of years ago. So where did life come from? We still don't have all the answers yet, but by studying biology, chemistry, geology, and even space, we're piecing together the story of how lifeless matter transformed into living cells. The truth is, life's origin is one of the greatest mysteries in science, and you could be one to help solve it someday. Thanks for joining me on SnakeBros Kids. Next time, we'll dive deeper into fossils and the geologic timescale, the giant calendar of Earth's history. Until then, stay curious, young scientists. Life as we know it needs what two things?
Liquid water and a source of energy.
What do we call the region around a star where it is not too hot and not too cold for liquid water to exist?
The Goldilocks zone.
What does LUCA stand for?
Last universal common ancestor.